Hello! In this brief video, I'd like to talk to you about a few different things that we'll start the year with. One is the idea of units and the idea that there are what's called base units, which are sort of preferred units for measuring in physics. Another thing that I'm going to talk to you about is how to do unit conversions quickly and reliably. I know you've probably learned about unit conversions before, so this might be a little bit of a review. And then I'd like to do an example of a more complex problem involving a unit conversion. So, I guess I might ask, what do we measure distance in? What can you measure distance in? You can measure distance in miles or inches or centimeters. In physics class, we usually measure distance in meters. It's not that meters is provably better than centimeters or inches, but we'll be using meters for the most part in this class. What do we measure time in? We can measure time in hours or years. We use seconds. What do we measure mass in? We could measure it in grams. That would make a lot of sense. In fact, we actually measure it in kilograms. And so we'll express a mass of 5 grams as 5 times 10 to the minus 3 kilograms. This picture here is actually of a kilogram mass. This is not curricular, but it's kind of interesting. Distance is measured by the speed of light and an amount of time. It's the amount that light, it's the amount of distance that light travels in like 0.000000000, whatever it is, seconds. A second is actually measured by the time it takes for a particular type of atom to decay. A second, I guess, like a second is defined with the statement that a cesium atom has a decay in 0.0000000 seconds. But a kilogram is not related to natural law. It's actually a kilogram mass that's sitting over there in France. Other units, like the unit of velocity, is combinations of meters, seconds, and kilograms. So velocity doesn't involve kilograms, it's just meters per second. We'll learn that acceleration has units of meters per second squared. We will even find that the units of force are relatable to these 3 base units. Since we are relating things to these base units, we're going to be using scientific notation to talk about things like a gigasecond or a centimeter or a microgram. You are responsible for knowing the SI prefixes and their symbols. So this dashed in hot pink, that is something for you to memorize. Hopefully you already know a good bit of it. Giga, mega, kilo, centi, milli, micro. Micro is abbreviated with the Greek letter mu. Milli is abbreviated with a lowercase m. Mega, 10 to the 6th, is abbreviated with a uppercase m. So learn those. Okay. In this slide, I'd like to talk about a pretty good technique for doing unit conversions. If our task, for example, is to express 10 meters per second in miles per hour, here's the technique. Step 1. Write the given and the units of the desired outcome. So in this case, our given is 10 meters per second. And we're going to fill some stuff in here, and we're going to get a number of miles per hour. That's step 1. Step 2. Fill in the units only of the conversion factors you need. And you won't need to write it on a second line. You'll just be filling in what you wrote on your first line, but this is just for demonstration. Let's think about this. How are we going to go from meters per second to miles an hour? Well, we're going to need to get the seconds out of the denominator and introduce an hours in the denominator. So we're going to be multiplying by some number of seconds divided by some number of hours. We're also going to need to somehow get meters out of a numerator and get miles in the numerator. So how are we going to get meters out of the numerator? Well, we're going to multiply it by some number of meters in a denominator. And how are we going to get miles in a numerator? We'll put miles in a numerator. Now, here's the secret of unit conversion, is that if you multiply a number by 1, you don't change it. If you multiply this 10 meters per second by the number 1, then you don't change it. You just end up with an equivalent number of miles per hour. So that's what we're going to do. We're going to make conversion factors that are each mathematically equivalent to 1. Well, what can I do with this fraction here to make it 1? Well, 3600 seconds is 1 hour. So once I've already put the units there, I'm like, oh yeah, 3600 seconds is 1 hour, 3601. How can I put my numbers in this fraction so that the fraction is equivalent to 1? Well, 1 mile is 1600 meters. I remember that because 4 laps around a track is about a mile, and 1 lap around a track is about 400 meters, so 1600 meters is a mile. So we'll just take 10 numerically and multiply it by 3600 and divide by 16. But look what happens. It's not just that the numbers happen. This meters really does cancel. Oh, gotta pause the video. Okay, I'm back. So the meters actually did cancel. Meters in a numerator, meters in a denominator. Cross them out, and only the miles is left. Seconds in the numerator, seconds in the denominator. Cross them out, and only hours is left in the denominator. Okay. So let's do a quick example. The world's biggest ball of twine has a volume of 905 cubic feet. Let's express that in yards. So, okay, so I write down what I have and what I want. I want some number of yards. And so here, I'll do this. I'll be like, okay, 1 yard is 3 feet, and so 905 feet cubed times that, I'll divide it by 3. Does this work? It's very tempting to do this. No, this doesn't work, and the units show you that it doesn't work. If you organize your units correctly, then you can't make a mistake doing this. You can't accidentally put the 3600 in the denominator, which is the mistake I make every time if I'm trying to do this without thinking about the units first. And you can't make this mistake where you just try and divide this by 3, because let's see what happens. I don't end up canceling feet cubed if I just have 1 feet in the denominator. So that's no good. How do we do this? Well, 905 feet cubed times, what am I going to need? Let's do the units first. I'm going to need cubic feet in the denominator. And I'm going to do it this way. I'm going to say some number of yards divided by some number of feet. Quantity cubed is some number of cubic yards. And so that's going to work. That's going to have me have feet cubed in a numerator, feet cubed in a denominator. 1 yard divided by 3 feet, quantity cubed is what I need. So actually, I'm going to end up dividing with a 95. I'm going to end up dividing the 905 by 27. So 905 cubic feet is 34 cubic yards.